Hello everyone, welcome to AI Anytime channel. In this video, we are going to learn about the LangChain Expression Language or the LCEL in short. It's the recommended way of building LLM applications with LangChain. That's what LangChain recommends nowadays, and it has multiple benefits when you compare this with the conventional methods of chaining your workflow within LangChain. It has features like parallel processing. It has features like streaming responses, better integration with LangSmith for traceability. You can do batch processing. It has multiple standard interfaces that we're gonna see that when we are going to write the code. So now in this video we'll have a code first approach where we will also write coding while explaining each and every component, the standard interfaces, and how LCEL is different when you compare with the conventional methods. So let's jump in and start writing the code. All right, so let's start our experimentation with the LangChain expression language. You can see I have a Jupyter notebook here, and I'm just going to rename this and I'll call it something like LCEL or notebook. Now, so the first thing here, what we have to do, I will also write some markdowns to also explain theoretically a bit, that how it is different from the other chain interfaces that we are using. So right now, LangChain, so let me just write it. LangChain right now, provides two superior frameworks. LangChain provides two superior frameworks, uh, and those are like one is the chain interface that we used to, like earlier we used to work, we still work with the conventional method. Let me just write it like this, the conventional method. And the next one is the LCEL, which is very latest changes that have been made, or the latest release by LangChain, and that's an acronym for uh, LangChain Expression Language. So these are the two frameworks that we have right now. What are the advantages when it comes to using LCL, guys? So let me just write it over here. Maybe in the same markdown I would have written it, but let me just write it quickly. So advantages of LCEL, and there are many benefits when it comes to LCEL. The first one is asynchronous, and it has different types of supports. We will cover that in a bit. So asynchronous, it also has batch. It also has batch features. It also has streaming support, which is really cool. These are the few things, because the chains crafted in LCEL inherently cater to both synchronous and asynchronous interfaces, as well as batch and streaming capabilities that it provides. Now, this flexibility simplifies the process of starting with a synchronous prototype, and later you can migrate or transition it to an asynchronous streaming interfaces. That's why it's so important. Now you can start small with synchronous prototype, but later on when we are going into an MVP or production stage, you can now transition to an async streaming support or interface. Now the second thing is the fallback in chains. Now this is important. Now with LCEL, I'll also write it down for you. So with LCEL, any chain can readily incorporate fallbacks. Earlier it was not like that. There were some workarounds that we used to do, but with LCEL now you have any chain, retrieval chain, conversational chain, prompt chain, LLM chain, etc., that can readily incorporate fallbacks. So let me just write it over here. What we can write, any kind of chains can readily incorporate fallbacks. Now, why this feature is important, guys? So this feature streamlines basically your error management, and it also fosters the graceful handling of your entire workflow or the entire chain, rag chain, or whatever chain that you have there. Now, the next feature that we're going to talk about in this video is the parallel processing. And we're not only going to talk theoretically, we will implement one after the other, guys, in the coming part of the video. Now the next is parallel processing. Now so LCEL, it's composed LCEL composed chains inherently support parallel processing for all the components. Okay, so let me just write supports parallel processing for all, excuse me, for all the components. Now, this gives the LLM applications frequently incorporate lengthy API calls, and also you have, and the importance of parallelism we all know, right? Why its parallel processing are so important. The checksum and the lengthy API calls and all. Now, the last one that we cannot gonna talk about is, or maybe not in this video because that will be a the scope will become too big, to complete in this video. It has now integration with, of course, with LangSmith as well. So LangSmith as well. So, it provides you automatic logging of every step in LangSmith, and that will give you some observability and debugging or traceability features that you need. So these are the advantages of LCEL. We will cover 1, 2, 3. We will not cover 4 because that will require a different video. Now, to start writing some code and experiment with the LangChain expression language, what we need is we need the latest version of LangChain. Okay, if you are still in the older version of LangChain, that might not support over here. So let me just do a pip install. Though I have it, but I will show you which version you need. So pip install LangChain, and you need the 3.2.1 version. So let's just do 0.0.321. Now this is the version that we need, and it says okay, pip install LangChain. Ooh. Now I already have installed this particular version of LangChain, so I'm not gonna, again, I just wanted to show you. Now let's do some markdown. Now let me just add a couple of more cells over here, and here I will write a markdown. I also want to explain you. So now first let's write describe the chains. Also, how now you can describe chain with LCL. Basically, it's a new taxonomy, guys. It's a new taxonomy altogether. You can follow pipe. Earlier, we used to define in a different way. Let me just write it over here. So now, for example, if you have a prompt template, now imagine if you have a prompt template and then you have a LLM, right? So in that case, this is how, if you write it over here, this is how you used to write, right? Now this is written as prompt, and then use the pipe from your keyboard, excuse me, and then the model. This is how you write now. So let's first create a model prompt. Let's first create a simple chain, the LLM chain. So let me just write it over here. Now let's import. So from LangChain dot prompts, and I'm going to import the chat prompt. So import chat prompt template, and then from LangChain dot chat models. So let's just do the chat models and then import the chat OpenAI. I'm going to use OpenAI GPT 3.5 model into this. Let's just import this now. Now the next thing is we need a model. So let's do a model, and model is nothing but the chat OpenAI. I'll set a temperature value, only inference parameter that I'm going to tweak here, and I'm going to call it 0.5. Okay, so the model we are now getting our model here, and it's a oh, did not find. Okay, we have to do a necessary step here. So let's do import OS. We have to set the API keys, guys. Okay, so import OS, and then OS dot. I'm gonna do invan. So OS dot invan, and then inside this, I'm gonna write OpenAI underscore API key, and then this is your key. So I already have key handy with me. Of course, I will delete this key when this video is once this video gets recorded. Now let's just put it over here, and it says okay, it's import os.invan openai underscore API underscore key. I don't have I don't have, this is surprising, I don't have import OS. Excuse me. Okay, you don't need this OpenAI, guys. Okay, let me just, but anyway, let's keep it. You can remove it because we're gonna use chat OpenAI. I was giving double equals. I thought I'm gonna install it, but not. So you have the model now. So now let's have a prompt. So prompt equals, and I'm going to use chat prompt template. And in this chat prompt templates, I'm gonna do dot from templates, from template. And here let's have a simple something. Let's do a something like related to joke or something. So tell a joke, about the topic. So topic becomes a variable here. This is how you write. Topic is your variable, and we'll give the topic. Now, how do you use LCEL, the LangChain Expression Language, for this particular chain that we're gonna create, the LLM chain? So let's write that. Chain equals, then first input is your prompt. So prompt goes, and then goes your pipe, and then you do the model. So basically, this is how you, this is the taxonomy of LCEL now. So let's just do a run. Now, once you do a run, let's just do a chain or print it. Now here you can find it out. Chat prompt template, your input variables is a topic. As I said, this is going to be your input, and then you'll have like messages. You're passing all the prompt to human message prompt template. Template is tell me a joke. Then you have this LLM. This is the LLM. The first one is related to prompt. The second one after pipe is related to your model, the LLM. You can find it out the temperature, the keys, and everything is over there. Now let's see how first we gonna, let's first give an example. Here, let's give you an example of streaming responses. Then we'll go into runnable or standard runnable protocols. We'll see that after this. Now, streaming response example here. So streaming responses. So now I'll say for excuse me, for s in chain.stream, for s in chain.stream, it's a function, and inside this it's a key value pair that we're going to give here, topic, and let's keep the topic here. So I'm going to first give programming, as one topic, and I need a joke on programming. Okay, so there can be a number of jokes on programming, but let's do a print here. So print, how do we go? S.content. So S.content, so let's just do content and end with end, and then let's just do plus equals true. Okay, so we do plus equals true. Now once you do that, you will see I've got a streaming responses here, and let me just come a bit down. You can see, why do programmers prefer dark mode? Because light attracts bugs. This is like really famous, right? Now this is how you do a streaming response. We'll look at more streaming responses, but let's first talk about something called the Runnable protocol. The lang, it's one of the, and some of the LangChain components. So let me just write it over here in a markdown. So let's do LangChain components and the Runnable protocol. So guys, LangChain components, right, implement this Runnable protocol, and this protocol basically provides a standard interface for defining custom chains and invoking them in a standardized manner. Because so you can define your custom chain, and then you can invoke them in a standard manner. That's what it provides. So let's now do that. Okay. So let me just write a couple of more markdown to give you the extent what are the interface which is available. So let's first write about standard interface, and here there are three primary interfaces which are available. The one is stream, the second one is invoke, and the third one is batch. These are the primary standard interfaces includes, and these and there are asynchronous. So in asynchronous, you also have something called a stream logs. So these three will remain common for both synchronous and asynchronous. But for this asynchronous methods, we'll have one extra method that is called a stream log, where you can stream back the intermediate steps in addition to the final response. So it gives you the traceability of under like what's happening under the hood. Now, so let me just write it. So maybe you can use this as your this notebook as your reference guide as well. Now stream back chunks of response. Pretty much self-explanatory. Now what do we mean by invoke, guys? So invoke just invoke the chain with an input. Invoke chain with an input, and then batch main in list of input. So you can invoke chain with a list of input. Python list, a list of input. Now this is on the standard interfaces. Now we also have something for asynchronous methods as well. So let's write it down here. That for asynchronous we have a stream, then we have a invoke. Just writing the taxonomy here. So when you are writing the code, you will remember the terminologies here, like a stream, a invoke, a batch, and there is important, which is really going to be important for RAG kind of implementation, which is a stream logs. Let me just write it down here. And I don't know why really it happened like this, but whatever, I think it's fine. Okay, so these are for asynchronous. Now, if you talk about the input type and the output types, so let's just add a few more cells and what was that? Input types. So let's first talk about the input types. So depending on your component, there can be n number of inputs. The first one is prompt, of course. So prompt, which is a dictionary. Let's also write the data types. Prompt is a dictionary. Then you have a retriever. If you're working for some RAG kind of an implementation, if you are doing, it's a single string. And if I have to give extra gap, I'm not following the right markdown format, but it's fine. Then you have your LLM, or you have your chat model. Now this can vary. So this can, according to my knowledge, this can be a single string or the message list, or it can also be a prompt value. Now a couple of more that we can write. A tool, if you want to use some tools, it's again depends on the tool. I think it's both. I think it's single string and it's also a dictionary, depending on which tool you are using. And then you have, excuse me, then that it had an interesting feature now that's called output parser, that helps you parse the output, and which is really cool. So output parser, and this is depends on the parser. It has n number of parsers, depends on the parser. It has a string parser, it has a JSON parser, etc, etc. Now this is the input types. Now the output type will be let me just write it. I'll copy paste here for you, so you can just output parser. Oh, not output parser, output types. I'll just copy this thing here. Okay. And in this, I'm just going to paste, and the first prompt is your string. Output becomes now an output. You don't have a prompt, by the way, sorry. You have an LLM that is going to be a string, and then you have then in you don't have a you do have a retriever, so that will be a list of documents now, that what you fed it to a large language model when large language model generates with the source document and all. Right, now you have a chat model. You also have a chat model, so let's just write chat model, and this is going to be your chat message. The prompt, so let's just write a prompt, and this prompt thing becomes it's a prompt value of the prompt, and then you have the output parser remains output parser. You can again have a tool here, so tool, and it's not in the order guys, order right now guys, this output types. So its tool can be depends on the tool, which data type depends on the tool. So these are the types of input and outputs types in the LCEL, LangChain Expression Language, and these are the standard interfaces available. So you can do chain.stream, chain.invoke, chain.batch, chain. Whatever, you can do that. Now let's write some code to see the schema. If you want to see the schema, right? So see, the input type and the output type schema is available through Pydantic data validation as well. That's what it uses. Now you can inspect the schemas for both input and output. So let's see how you can inspect that. So you can do by chain dot input schema dot schema, which is a function, and you can see this is your input schema. Okay, you have a prompt input and type is object, blah blah blah, right? And similarly you can also do for prompt thing. So prompt dot input schema dot schema again, and let's do that, and you can find out the prompt thing over here. Now what else we have? So you can also do model thing, I think. So model input schema dot schema, let's do that, and you can find out the model input schema as well, and you can also do it for output. So let's just do chain dot output thing here. So I'm gonna just do chain dot output schema dot schema, and you can find it out over here. This is your output schema. Now let's use some method guys. So let's start writing. The first is invoke. So let's just do chain dot invoke. It's the standard interface that we have, and here in the chain dot invoke, let's pass, it's a function, and in the function you're gonna write a key value pair, because you have to give a variable for topic, and the topic, let's give football for example, and let's see what it gives. When I did chain.invoke topic football, it gives me, it's not streaming by the way, it's just invoking the particular chain, and it says with an input which is football. Why did the football team go to the bakery? Because they needed some dough. Oh, okay. Let's look at the badge thing. So chain.batch, and here you can also give, now it's a list of inputs that you can provide. So remember, it's a Python list. Okay, so let's first give a list. This is how you define a list, and inside this again it's a key value pair because you are giving a couple of batches. So let's just do a topic, and here you can do like AI for example, and then after this curly brace, come out of this, create one more curly braces, and in topic once more topic, you can give n number of that, and here let's write like something like science. Once you do that, you will find out some AI message like content. Why did the AI go on a diet? Because it had too many bytes. Why don't scientists trust atoms? Because they make up everything. Okay, now you already have seen stream. Now what you can also do, because a few of the time you will have this question that what to do with the concurrency, how many parallel requests, or not parallel, how many concurrent requests you can make when you are doing a batch. So let me just show you. This also has a feature for concurrency as well, the maximum concurrency, excuse me. Now that you can give it as a config parameter. So in config, you can look at it over here. It's like a key value pair. Just give a maximum concurrency. So max concurrency, let me just write it over here. And here you can define, so let me just define 5 here. And this is how you can, also handle the concurrency when we're using LangChain Expression Language. Now this with the sync, let me just add a markdown so you'll be able to see. Now let's do an async here. Async invoke, let's see that. Okay, now with the async, let's just write async for s in chain dot a stream. You're gonna use a stream. You can see all the functions available: a stream, a invoke, a batch, and a stream log, a transform, everything. So let's use a stream, and here in a stream I'm gonna pass a topic. So topic, and that topic becomes your, let's give satellite for example, and here you're gonna just do print. So print, what we're gonna print guys? Content. So s dot content, excuse me, s dot content, and after content you're gonna end with an empty, so end, and then you're gonna do plus equals true because you are using streaming here, so plus equals true. And once you run this, you will see it's streaming, right? Why don't satellites ever get married? Because they prefer to orbit around. This is really cool. Now so let's now look at the maybe the batch, a batch. So let me just copy it, this entire thing, and I'll paste it over here. And chain dot a stream, you just have to make this. But when you use batch, right, you cannot directly give async for s like we are doing. We have to use await. You have to wait for it, right? The response generating for the batches. Now, so what we're gonna do here is we're gonna use await keyword. So await, and then chain dot batch. And here again it's a Python list, so let's just copy the above thingy. So where we had a batch, here we had the batch. Let's just copy this. Let's just copy these two things here, Control C, Control V, and in the batch here let's just write Control V, and this is what your the batches are, and you don't need this thing here. Okay, now here we're doing await chain dot batch. You have couple of topic AI and topic science. Oh, await expression. It's not batch. My bad. It's a batch. Excuse me. It's asynchronous batch. Okay. So await chain dot a batch, and then you give the topic AI or topic science, whatever. Okay. And you can look at it. Will take a bit of time. So let it go. Now, meanwhile, we can also do. Let's add some extra cells over here. And you can see we got our response. Why did the AI cross the road? To optimize its path finding algorithm and collect more data on pedestrian behavior. I really love this. I really love this joke. Why did the scarecrow win an award in science class? Because he was outstanding in his field. This is really creative. Uh, Now, what to do with async stream? Like when you have intermediate steps. Let's just do that here. So let's just write async stream with intermediate steps. Now here you have to install fast CPU because I'm using a CPU right now. I'm not utilizing my GPU. And then you also need tick token. So I'm not gonna do that because I already have installed. So you can install that. Now let's execute the retriever chain here first time, and then output the intermediate steps using the a stream log. Just gonna output that steps that we have in intermediate that when we are using a chain. So for that, from LangChain dot embeddings, I'm gonna use embeddings here. Import OpenAI embeddings. Let's use, oh, it has Octo AI as well. I want to use OpenAI embeddings. Excuse me. OpenAI embeddings, and then from LangChain dot schema dot, let's have an output parser as well. So this is how you can use an output parser. I'm going to use string output parser. Now what else we're going to do? So from LangChain we need the vector store. So let's use vector store, import fast. So import fast, and we need one more thing. We need the runnable runnable pass through. So which is available in LangChain.schema. So from LangChain.schema dot runnable, import runnable. What is that? I think it's runnable pass through. Yes. Now you can see I have imported successfully. And now here what I'm going to do next is let's have a template here. So template, a very simple template, like let's have a docstring first, and inside the docstring let's start writing, please answer the question based only on the following context. We'll not use a PDF or something like here. Very simple couple of queries that we might give, and we just try it out. Now here you can define a context as a variable, and then you have question, and your question is question. This is what your question is. Now let's do excuse me. And now let's do a prompt thingy here. So prompt equals, we're gonna use chat prompt template dot from template, and here we're gonna pass our template that we have on top. Template. Okay, now this prompt, let me just go up so you can see it, and the prompt, and then let's have a vector store. So vector store equals fast from dot text, because we are not using a document, so let's use a single text here, and I'm gonna just give a context. We can give it in a Python list, and I'm going to say Sonu is the creator of AI Anytime YouTube channel. Now this is my one of the context, and what we're gonna do here is let's pass this embedding thingy here. So embedding becomes our OpenAI embeddings. Okay, OpenAI embeddings dot missing one required positional argument texts. So fast dot from text. Sonu is the creator of, and then you have okay, my bad, it's a function. Now I don't know why I didn't use the function. Okay, now we have the vector store. Now let's use the retriever. So retriever, and retriever is nothing but your vector store dot as retriever, and in here we're just going to load this retriever, and then let's have a retrieval chain. Now this is important. Here we are going to create a retrieval chain using LCEL, the new expression language. And how do we do that? Okay, so you do this, and inside this you first define your whatever context that you're gonna have. So here for context we're gonna do retriever dot does it give with config? Yes, with config, and let's give it a name. So that let's give it this runnable protocol as a name. So I'm gonna give run name. Oh, this is strange. It didn't suggest me. I don't know what wrong. Are we doing anything wrong? Docs. And then your question. So this question is nothing but your runnable pass through. So runnable pass through, which is a function. Now here you give a pipe, and then you write your prompt. The next thing is prompt. Again you hit enter, or you can give it in the same line, it's okay. And then you go to your model. Again you hit enter, give a pipe. You can do in the same line again, and here you're going to give the output parser, which is a function. Let's see that. I don't know why I'm feeling that this might. Okay, now let's just print this retrieval chain. Now once you print the retrieval chain, you can find out everything which is there inside the chain, guys. You know, like a pipeline. You know, if you have used the scikit-learn pipeline, you would have seen this. If you have worked with the haystack pipeline, you would have seen something like this. You know. Now what we're gonna do next is let's use async here. So async for chunk in this retrieval chain.astream, and we're gonna use astream log to look at everything in the intermediary step, that how it's working, because guys LangChain like provides high level abstract classes. Sometimes you want to look at the logs, etc., that what is happening, right? And that's what available inside LCEL. Now let's write the question. Now I'm going to ask this question: who is the creator of AI Anytime? I'm asking this question, and here what I'm going to do is I'm going to do an include names, and my names are nothing but the docs that we have defined on top. That's a good rhyming, docs, and we're just gonna print this. So let's multiply this with 40 print, and then let's just print chunk, and you can find it out. Let me just go below, and you can find it out everything, and you can also, if let me first show you the output. Our question was, who is the creator of AI Anytime? We have given this context over here. If you look at this, is the context. Sonu is the creator of AI Anytime YouTube channel. We created the embeddings, the vectors, and we stored them in a vector store, a fast vector store, and then we use this inside a retrieval chain. Now the question that I ask, who is the creator of AI Anytime? You can find out everything. The output is Sonu is the creator of AI Anytime, but let's look at above that. So we have everything is streamlined. That's why we're using the slog. You can look at the tags, the counterfacts, the open embeddings, the retriever type, the docs, the metadata, everything which might be there will be available here as well. And you can see the output. Now, I also want to show very quickly, and after that we'll wrap it up. I want to show it to you something about parallel processing as well, that how you can do parallel processing when it comes to LCEL and this runnable parallel. So we have a method now, runnable parallel, that allows each element to run in parallel method. So let me just write it down here as well, adding 4 5 cells, and then here I will just write one more markdown so you can just look at it. Runnable parallel. So allows each element to run in the parallel. Okay, now let's see some examples, guys. So how can I import that? So from LangChain dot schema dot runnable, and here I'm just going to do import runnable parallel. Let's import that, and I'm going to create a couple of chain here. So chain 1, and in chain 1 let's have a chat prompt template dot from template, not from messages, from template. And here let's define one thing, like let's keep the joke thingy going on. So tell a joke about certain topic. So about topic. And here I'm gonna also give my model. So LLM, let's bind it together. So this is our chaining, right? We're chaining it. You can see the pipe model. And let's have a chain 2. So chain 2 again, chat from template dot from template. And here let's have something else. So let's write like poem or something. So write a short, like two lines poem about this topic. And here again the LLM goes, so model, piping it together. So model, and then we're gonna combine. You can also combine it, guys. That's the beauty of it. Let's combine that together. So I'm gonna just do combined as well. So combine equals, and and that's where you're gonna use runnable parallel. So runnable parallel, and here you can now give joke 1, just give a name joke, and this is chain 1, and give a name here poem joke 2. Sorry, not joke 2, chain 2. Okay, now let's look at combined first, and you can see the combined chain that we have now. Now let me just add a couple of here, and let's use timing. So %time, and here because we also want to see the execution time that it takes. Okay, so chain, let's do a batch thingy here, and I'm gonna use topic, excuse me, and let's keep topic as like love, for example, and the other one as topic, and let's keep romance, for example. Okay, and let's see that something I'm doing wrong. This is wrong, this is not here. I have to end the list here, and it says okay, I have to do this and I have to do this. Okay, now chain 1 dot batch, and we have, you can see it over here, total time that it takes, right? Why did the two lovebirds go to therapy? Because they had commitment issues and kept tweeting instead of talking. And why did the couple go to the bakery? Because they needed some Dobermans. Oh wow, this is great. Now let's look at the other chain as well. So chain 2, keep the topic thing is same. So chain, and this will create a poem for you. Okay, so let's see the poem, and we'll see the combined thing as well. And it takes a bit of more time because that's had to generate some poems and all. Let me just add one more cell here, and here we'll use the combined thing. We are not using time here, but it's fine. Let me just copy this here, And here I'm just gonna use combined. It will take even more time, the combined thing. And you can see we have got love a gentle breeze, whispering secrets through the trees. In love's embrace, hearts dance and ignite, romance's flame, a passionate delight. Wow, that's a good rhyming. And here the combined dot batch, and let's see that. And it will take a bit of time because it has combined both the chain 1 and chain 2 to basically, first it will give you the joke, and then it will give you the poem. Okay, so let's see that it will have 4 responses. You can see the joke, poem. Why did the tomato turn red? Because it saw the salad's dressing and fell in love. Love, a gentle flame that warms the soul, binding hearts together, making us whole. uh, wow, love's sweet whispers, hearts entwined, romance blooms, forever wine. Fantastic. So, I mean, let's stop it here, guys. I mean, this is what I wanted to show you, with LangChain expression language. I'll give this notebook on the GitHub repository, which you can play around it, and let me know your findings with LangChain expression language. So that's all for this video, guys. I hope you learned the basics and the fundamentals of LCEL, the LangChain Expression Language, and the code will be available on the GitHub repository. You can just go fork the repository or download it and play around it with LCEL. And if you like the video and if you like the content that I am creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel, guys. Share the video and channel with your friends and to peer. If you have any questions, thoughts, feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Those informations are available on my YouTube banner and the channels about us. Thank you so much for watching. See you in the next one.